Welcome student. Let's have basic idea about speed math and also let's learn few mathematical tricks to calculate the answers. You all must be wondering what is speed math. Speed math is basically a guide for becoming genius. It makes the calculation part 10 to 15 times faster. It helps you in making intelligent guessing. It reduces your unnecessary burden and also improves your mental calculation and increase your concentration and improves your confidence level. After learning about speed math, we guarantee that you will throw away your calculators and will prefer to do calculation mentally rather than using pen and paper. Believe it or not, but this is true. In Speed Math series, we will learn how to multiply any number from 11 to 19, how to multiply numbers with common base, how to do squaring and cubing of a number, as well as how to multiply 2 and 3-digit numbers in much shorter and easiest possible way. Have a look at these. Let's see how to multiply 123 by 11 in few seconds. First of all, we will prefix 0 to it. We get 0, 1, 2, 3. Now we add the right neighbor of each digit to it. Simply there is no digit to the right of 3. So we will be adding 0 to it. This will give us 3. Now we will add right neighbor of 2 to it. So that makes the total as 5. Similarly add 1 and 2. So that gives us 3. Now add 0 and 1, which will simply give us 1. Now write down the number from down to top. So our answer will be 1353. Isn't it easy? Now you try and multiply any number with number 11. Similarly, let's look at how to multiply 13 by 12 in few seconds. Now over here the method is exactly the same as in the case of 11, except that you double each number before adding the right neighbor. First of all, prefix 0 to it. We get 0, 1, 3. Now double each digit and add the right neighbor of each digit to it. Since there is no neighbor on the 3, so twice it and add 0 to it. This will simply give us 6. Similarly, twice the next digit 1 and add the right neighbor 3 to it, which gives us simply 5. Similarly, twice the next digit 0 and add the right neighbor 1. This will give us 1. Now write down the numbers from down to top. So our answer will be 156. Now this was a glimpse of speed math. We will continue in our next session. Till then, goodbye and have a nice time.
Hi. Okay, before I start this class, I would like to ask you a question. Cross your heart and tell me, do you actually believe that your mind can calculate faster than the calculator? I certainly do. And with every video, I'm going to make your belief in your own mathematical ability grow stronger. And I'm not going to stop till I actually make you throw your calculator outside the window. Alright, so here goes another easy cal trick for you. Can you find out what is 98 times 97 in 5 seconds? Okay, so your time starts now. I think the time is up. The answer is 9506. Well, those who could not calculate, don't get disheartened, because you know that you just have to learn this trick and then you'll be able to multiply any numbers that are closer to base 100 in less than 5 seconds. The smarter way of multiplying 98 times 97 would be, watch me. That's your answer. Was it too fast for you to follow? So, let me give you a very slow motion action replay of what I have just done. Okay, so what I have done here, that I have used the same base method of multiplication that you must have learned in the last video. The base here, right, you guessed it right, it is 100. Now 97 is 3 less than 100, so I put minus 3 here, and 98, right, is minus 2 less than 100. Now in a cross fashion, I subtract from 98 this 3. So 98 minus 3 is 95, and you'll get the first two digits. Or 97 minus 2 is again 95. So whether you do 98 minus 3 or 97 minus 2, it's one and only same thing. Alright, and for the last two digits, what we do? We times this. So minus 2 times minus 3 is, right, positive 6. But the base here is 100, so there are two places to go. So we put 06 here. You try to find out this time. Alright, so what is 95 times 99? Okay, so first step, write this. Second step, 95 minus 1 is 94, and the answer is 9405. See, so simple it is. In fact, you must try to do it mentally. In the next trick video, that is Easy Cal 8, we would be learning how to multiply the numbers above 100, like what is 104 times 107, or what is 105 times 109. Thanks for watching this video. Take care.
What we do in life, it goes in eternity.
In these days, our days
Welcome to another 5-minute faster math class of Glad to Teach. So let's start this class right away. My question to you is, can you mentally find out, and the emphasis is on the word mentally, what is 104 square? In other words, what is 104 times 104? You get 5 seconds for that and your time starts now. Give it a try, I know that you can. Your time is up. The correct answer would be 10816. There it is, 10816. So now let me show you the easy cal trick for finding the squares of the numbers the faster way. To find the square of 104 the faster way, all you need to do is add this 4 to this entire number. So what is 4 plus 104? It is 108. So you get the first 3 digits of your answer. Now 2 more digits to go. So what is the square of 4? It is 16. So that's your final answer, 10,816. Voila! Isn't that simple? Simple and fast. Could you understand what I have done here? Okay, so let me explain it to you a little. Basically what I have done, I have taken the base as 100. Now 104 is 4 more than the base. So immediately add that 4 to this entire number. So 4 plus 104 is 108 and you get the first 3 digits of your answer. Now since base 100 has 2 zeros, so 2 more digits to go. So what is the square of 4? Again, we just square that distance. So square of 4 is 16. So the answer is 10,816. So now you find out quickly what is 107 square. Come on. So once again, add this distance from the base 100 to this entire number. 7 plus 107 is 114. Now 2 more digits to go. 7 square is 49. So your answer is 11,449. That's it. So what about 112 square? Come on, find it out. So once again, add this 12 to this entire number. So 12 plus 112 is 124. Now 2 more digits to go. So 12 square is 144. So write 1 here, 4 here and the other 4 here. Now the answer would be 125.44. That's your answer. Now don't you think that with this method you are not only calculating fast but easily as well, because there are less number of steps involved. Now what if the number that we are trying to square is below the base, that is below 100? So how do you think we are going to go about it? Once again the same thing. 96 is at the distance of minus 4 from 100, isn't it? So subtract that 4 from 96. 96 minus 4 is 92 and you get the first 2 digits of your answer. Now 2 more to go. What is the square of this distance? 4 square is 16. So the answer is 9,216. That's it. Now you know that you need not be a math genius or a math wizard in order to do super fast mental calculations. All you need to know is these simple tricks. By the way, in the next easy cal trick, we would be learning the faster way to find the cubes of the number. That is, number multiplied with itself 3 times, like 86 cube. It would be 86 times 86 times 86. So we'll be learning how to find the cubes of any number from 1 to 100 the faster way. And you'll realize that it is as simple as finding the squares. Hi. Welcome to another 5-minute class of Glad to Teach. Hey, before we start this class, tell me something honestly. Did you try to impress somebody with these amazing tricks? I'm sure you must have. So here is another piping hot trick for you straight out of the oven. can you mentally find out what is 13 times 12 in 3 seconds, that is? I know that you can, so give it a try. Your time starts now. Your time's over. Well, if your answer was 156, then that's terrific because you are calculating faster than the calculator. In case you could not calculate at all, not to worry, for you know that in next 4 minutes you'll be able to multiply any numbers closer to base 10 in less than 3 seconds. So let's see the usual way of multiplying 13 with 12. So 2 3 times is 6, 2 1 times is 2, 1 3 times is 3, 1 1 times is 1. Now add the numbers in the column. So 6, 3 plus 2 is 5, and this is 1. I know you must be getting impatient. You must be saying that cut this harder way. I'm already sick and tired of it. Show me the smarter way. So here is your smarter way. The smarter way of multiplying 13 with 12 is the same base method of multiplication that we learnt in the last class. And yes, you guessed it right. The base here is 10. So since 12 is 2 more than the base, so add this 2, that is this digit, to this entire number. 13 plus 2 is correct, 15. And since base 10 has 1 0, so there is one place more to go. 3 2 times is 6, and that's your answer. Isn't that simple? You bet it is. Okay, so let's take one more example, and this time you try to solve it. Okay, there you go. What is 13 times 13? Okay, so first thing you did was to add this 3 to this entire number. 13 plus 3 is 16, and 3 3 times is 9, so the answer is 169. Isn't that simple? Right. Okay, so let's take one more example, and be careful this time because I'm going to set up a trap for you. What is, let's say, 16 times 12? So add this 2 to 16. 16 plus 2 is 18. Now 6 2 times is 12, and you know that 12 is a 2-digit number. So, and there is only one place here to go, so carry forward 1, write 2 here. So the answer is 192. Isn't it? So this way, see, these are very common operations. No matter what question of mathematics you're trying to solve, you have to multiply the numbers. So if you know these techniques, then you'll be able to multiply quickly and correctly. Okay, so before we end this class, let me give you one last example. What is, let's say, 18 times 14? So first thing, add this 4 to 18. 18 plus 4 is 22, right? So 8 4 times is 32, so carry forward 3, write 2 here. 22 plus 3 is 25, so the answer is 252. That's your answer. Isn't it simple? So see you next time with plenty more such cool tips and tricks. Bye bye.
Multiplication is easy. If you can multiply the numbers between 1 and 4, then you can also multiply by 5, 6, 7, 8, 9 and 10 using nothing more than your fingers and thumbs. Put your open hands in front of you with your palms facing upward. Your fingers and thumbs are going to represent the following numbers: 6, 7, 8, 9, 10. Your thumbs are always a 6. Your little fingers are always a 10. Say you want to multiply 7 by 9. On your left hand, put down all your fingers up to and including 7. On your right hand, put down all your fingers up to and including 9. Now any fingers that are down each count as 10. We have 6 fingers down, so that's a total of 60. Now the number of fingers left standing on each hand are multiplied together, which is 3 by 1, which is 3. Adding together our first total of 60 to our multiplication result of 3, we get 63. And yes, 7 times 9 is 63. To show it's no fluke, let's try another multiplication, say 8 times 6. This time we have a total of 4 fingers down, each worth 10, so our first number is 40. On the left hand, we have 2 fingers standing. On the right, we have 4 standing, so that's 2 times 4, which is 8. So our result this time is 40 plus 8, or 48, which again is the correct answer. You can actually use the same technique to multiply by 5, but you don't put any fingers down on the hand representing 5. I hope you found this interesting. Thanks for watching, and please check out my other videos.
Do you know the fastest way to add 2 plus 5 plus 8 plus 7 plus 4 plus 3 plus 5 in your head? Keep watching to find out how. Hi, I'm Jason with MathTutorDVD.com, and today we're going to begin our quest in getting really good at mental arithmetic, and we're going to learn to crawl before we walk, and we're going to do that by really working and practicing with single column addition. Now, in order to do this and speed it up so that you can get good at it in your mind, there's 2 things that you need to remember. The number 1 thing is you're going to add the numbers as usual, so we're not going to use any fancy tricks to actually add 7 plus 4 together. You're going to have to get good at it, have it on the tip of your tongue, but we're going to add the numbers as usual. And the second thing we're going to do is we're going to look for our complements, which we've learned how to do in the last section. And you're going to see here in just a second how that's going to really speed up the process. Okay, so here's a pretty easy arithmetic problem, 3 plus 4 plus 7. Now, I'm absolutely confident that everybody listening to this can actually do this problem, definitely on paper and almost certainly in your head. But the way most people are going to tackle this is they're going to start at the top, and then they're going to look at 3 plus 4 is 7. And then 7 plus 7, you might have to think about that a little bit longer, but then you'll come to the answer of 14, and that is the actual correct answer. Now, this is pretty easy because there's 3 numbers in the problem, and so most people can do addition of three numbers in their head without an issue. But you know, depending on the numbers that you have here, you might have to think a little bit harder, but most people are going to start at the top and work their way to the bottom. I want you to not do that from now on. Whenever you look at a list of numbers or hear a list of numbers, I want you to look for complements. And so what we're going to do is look at this again from a different point of view. Notice we have 3 and 7 in this problem. So immediately, because we know that 3 and 7 are complements from our previous lesson, and we've drilled that into our head, we know that this makes 10. 3 and 7 make 10. So putting a little mark here to remind ourselves, those 2 add to 10. So that's already 10, and so you know that 10 plus 4 is 14, and that's the answer. Most people would agree that doing this is faster than doing 3 plus 4 is 7, 7 plus 4 is 14, because especially when you get to a long list of numbers, if you can find pairs of numbers or even triplets of numbers that sum to 10 and mentally check them off in your little head, then you're going to eliminate most of the list of numbers doing something very easy and simple. But the key to it is knowing those complements, basically having them almost memorized. So let's look at another example. 2 plus 9 plus 8. Again, most people would do 2 plus 9 is 11, 11 plus 8 is 19, and that is the answer. That's true. But let me give you a moment to look at this and identify the complement. Well, you can see that 2 is a complement with 8, so that immediately sums to 10. 10 plus 9 is 19. And so you'll see how this is going to get faster. Now, from here on out, we're going to be using the exact same process no matter how long the list of numbers is. Just we're going to look for more and more pairs of numbers that make our complement. So what we're going to do now is I'm going to write the problem on the screen, and then I'm going to give you a moment to look at it. I encourage you to pause the video and try to identify the complements and get the answer that way. And then when you're ready, go ahead and press play, and you can watch this section as many times as you need. Okay, so here we have 1 plus 4 plus 5 plus 6. Go ahead and take a look at it, try to identify the complements and add it up that way. Alright, so what we're going to see here is we notice we have a 6 and a 4 right there, so that sums to 10. And I'm saying, okay, I've got 10 right there, and I've got, that's 15, and then that's 16. So here's the answer, 16. So again, I'm looking at these two, I'm identifying 10 off the bat, I'm looking at the plus 5 gives me the 15, plus a 1 gives me 16. Okay, here we have 2 plus 9 plus 8 plus 1. Most people would start at the top and add up through the bottom, but take a moment, pause the video, find your complements, and find this answer. Okay, so what we have here, notice that 2 and 8 are complements, so that makes 10 right away. Also notice that 9 and 1 are also complements, so that makes 10. So the answer is 20. Now that's much faster than doing, okay, 2 plus 9 gives me 11, 11 plus 8 gives me 19, 19 plus 1 gives me 20. What we're looking is we're scanning the pattern, almost like you read a word in a book. You don't sound every letter out anymore. When you were a kid, you had to do that. But when you do math, you need to start to look at these lists of numbers and don't sound them out, so to speak, by adding them up top to bottom. Look for those complements because it's going to cut your computation time, you know, way, way down. Okay, now look at this problem. 4 plus 7 plus 1. Now we don't have a pure complement here that we can really pick on to save ourselves some time, but we do notice that we have a 7 and a 4. And one thing that I do when I see something I don't quite have a complement here, I know that 7 and 3 is a complement. That's going to give me 10. So I don't have a 3 here, I have a 4, so I'm going to have 1 left over. So I've got the 10 plus the 1 up here plus the 1 down here is going to give me 12. And you can do it any way you like, but you're going to find that especially when the list of numbers gets really long, that is going to actually be much faster for you to look and say, well, I almost have a complement here, so I'll keep track of that as 10. I've got the 1 left over and the 1 here that gives me 12. Now here we have another problem, 6 plus 2 plus 2 plus 5 plus 9. Pause the video, take a moment, and try to do this problem. Now what we see here right away is that we're looking for a complement. We don't see something right away, but I notice that if I take 6 and 2 and 2, all of that together makes a complement because 6 and 4 are complements. 2 plus 2 makes 4, and so all of this together is going to sum to 10, and that just comes off the tip of your tongue because you know that 6 and 4 are complements. And so you have 2 and 2 and that make 4. So mentally I track all three of these first numbers as basically 10, and then I look at the rest of my problem and go from there. 10 plus the 9 gives me 19. I can do that very fast. 19 and 5 is going to give me the 24. And it saves you basically over half of the problem by doing it that way because you have three numbers you don't even have to worry about once you identify them as summing to 10. Okay, here we have 8 plus 7 plus 4 plus 3 plus 6. Pause the video and figure out the answer. Okay, so the first thing you do is you start to scan for complements. We notice that 7 and 3 are complements, so that's going to be 10. We notice that 4 and 6 are complements, that's going to be 10, so we're up to 20. All we have left is 8, so we have 28. And I promise you, once you get good at knowing those complements, that is going to be much faster than taking 8 plus 7 plus 4 plus 3 plus 6 to get the answer. And the last thing I'm going to say before we do a few more problems here is when you're doing this in your head, I don't want you to sit there and use the word plus in your head. I don't want you to say 10 plus 10 is 20, plus 8 is 28. You can do that if you want, but what I prefer to do is just say the numbers, because anytime you use a word in your head, it slows down what you're trying to do. So the way you would say this in your head is 10, 20, 28. So you're looking and you're adding in your head and you're saying the new subtotal. So you have 10, 20, 28. That's how you would say that mentally. And as you go further, that's going to save you a lot of time. It's going to make you faster, but just like anything else, you have to practice it. Okay, here we have this problem. 9 plus 2 plus 3 plus 5 plus 1. Go ahead and pause this video and try out the answer. So what we're going to see here is we have some complements staring us in the face. We have the 1 and we have the 9. That's going to be a complement that's going to give us 10. So we're going to start at 10 and we're going to go from there. 10, 15, 18, 20. and that's going to give us 20. So we're trying not to use the word plus. That slows things down. But you know you have a 10 here, and then you have 15, 18, 20. That gives us the 20. Okay, now we're getting into some impressive problems. Here we have 7 plus 1 plus 4 plus 5 plus 3 plus 7 plus 9. Go ahead and pause the video and try to use complements to find the answer. Okay, now what we're going to see right away is 7 and 3 are complements, so that's going to be 10. And 9 and 1 are also complements, so that's going to be another 10. So right now, without really doing anything at all, I know I have at least 20. So now I'm going to continue. 20, 27, 31, 36. So 36 is the answer. Again, starting at 10, then I have 20 with my complements, then 27 off the bat, that makes it easy, then 31, and 36. 36 is the answer. Okay, now this is the problem we actually opened the section with. 2 plus 5 plus 8 plus 7 plus 4 plus 3 plus 5. Go ahead and pause the video and try to find the answer. Alright, so let's look at this. What we have is a bunch of complements staring us in the face. We know that 2 is a complement with 8, so that's going to give us 10 right there. We know that 7 is a complement with 3, and that's going to give us another 10 right there. And then we also know that 5 is a complement with 5, and so that gives us another 10 there. So really, we've really covered all of the numbers here except for this 4 here. So we have 10, 20, 30. 4 is the only thing left over. The answer is 34. Notice how much faster that is than doing 2 plus 5 is 7, 7 plus 8, 8 plus 8, 7, and just keep down and down the list. It's just going to take a lot of time. Just make sure to identify the complements and go from there. Here we have our final problem. 1 plus 7 plus 3 plus 1 plus 9 plus 4 plus 2 plus 6. Go ahead and pause the video and try to find the answer. Okay, now we just scan the list as usual and try to find complements. 7 and 3 are complements, that's 10. 1 and 9 are complements, that's 10. 4 and 6 are complements, that is 10. The only other numbers left over are the 2 and the 1, so I've got 10 here. This makes 20, this makes 30, 32, 33. 33 is the answer. So we scan for complements, we make a mental subtotal, we look at whatever we have left over and we add to that. It tremendously speeds up the process. I'm Jason with MathTutorDVD.com. I hope you've learned something from this. Please take some time to get a pencil and paper, write down a bunch of random problems off the top of your head and just practice it. And just like reading or just like playing an instrument or just like riding a bike, it's going to get more natural and more comfortable to you. And I guarantee you, once you can get comfortable adding these columns of numbers up, then adding a multi-digit number like, 347 plus 159 is not going to be that difficult, but we need to crawl before we walk. So we work with these one-digit numbers, these single column numbers, and then we add two-digit numbers and three-digit numbers and getting better and better and better, all the while increasing your skills in mental math. Hello, do you know the most important secret to mental addition? Keep watching to find out what it is. Hi, I'm Jason with MathTutorDVD.com, and today we're going to learn the most important secret to being able to do mental addition and subtraction. And it's something that every one of you already knows, but we're going to practice it here so that you get really good at it and so that we can use it. And that is knowing your complements. And we're not talking about, oh, you look great today. We're talking about the mathematical complements. What a complement is something that you already know, but we're going to drill it in here, and we're going to get so comfortable with them that they'll be on the tip of our tongue, and you're going to use it over and over again as you do mental math in your head. The complement of the number 1 is just the number 9. And so the complement of the number 2, as another example, is the number 8. So you can see from the pattern here, a mathematical complement in the context of what we're talking about is just the number that, so if the complement of 1 would be the other number, so that when you add these two numbers together, you get 10. So another example is if we're looking at the number 2, the complement of the number 2 to give us 10 would be the number 8. And what you're going to find out as you start juggling these numbers in your head is that knowing spontaneously what it's going to add together with to give you 10 is going to give you a huge advantage. And so, like I say, everyone knows that the complement of 3 really is 7 because you know that 3 plus 7 is 10. But what we need to do is get really fast at it. The complement of the number 4 is, for instance, the number 6. The complement of the number 5 is 5. The complement of the number 6 is 4. The complement of the number 7 is 3. The complement of the number 8 is 2. The complement of the number 9 is 1. And of course the complement of the number 10 is 0, and we don't really care about that because it's already 10. So what you're going to find is that as you start looking at long columns of numbers, you're going to be looking for sort of pairs of numbers that add to 10, because it's going to make your mental addition a lot easier and faster. So look at this list, say them to yourself a few times, play this part of the video again if you have to, and do more than just know these facts. Everyone knows that 6 plus 4 is 10, but what you need to do is when you look at the number 6, you need to immediately in your head think of the number 4. And the way I think of it is these are almost like two puzzle pieces. The number 6 and the number 4, they fit together perfectly to make that nice round number 10. The number 3 and the number 7, they fit together perfectly like a puzzle to make the nice round number 10. Think of it like that. It's going to make your life easier. So what we're going to do now is really do a quick little drill to practice our complements. And what we're going to do now is I'm going to write a number up here on the board, and you're going to yell out its complement as fast as you can. And you're going to play this part of the video as many times as you can and as many times as it takes for you to really feel that you understand these complements and that you can just yell out the complement immediately without having to really think, okay, what plus 6 is going to be equal to 10? I want you to be able to yell it out. And so that's what we're going to do here. It's going to help you tremendously. The complement of the number 6 is 4. The complement of the number 3 is, you can do it, number 7. The complement of the number 4 is, that's right, 6. Complement of the number 2 is, you got it, 8. Complement of the number 9 is, obviously it's 1. Complement of the number 7 is 3. The complement of the number 1 is 9. The complement of the number 5 is, obviously, 5. The complement of the number 8 is 2. Now, you may think this exercise is silly. You may think that it's something that everyone knows, but let me tell you, every step on a journey to getting good at something begins with practice and begins with really getting a good foundation. If you understand these complements, and if you can not only understand them, I know you understand them, but if you can get to the point where they're just naturally fall out of your mouth when you see them, then when you look at a long list of numbers, you're going to be able to put them together and add them together in a way that's going to make it much easier for you, and we'll get to those in subsequent sections. So play this part of the video again if you need to. Really get to the point where you can yell out your complements. Okay, now we're going to practice a little bit what we've learned a minute ago with complements and getting good at it, and we're going to continue practicing here, but we're going to twist it a little bit. What I'm going to do now is write a number down, and you're going to yell out as fast as you can how far away from the number 20 is the number. So you're really doing a little bit of mental subtraction here, but trust me, when you get into doing long column addition with multiple digits, it's going to help you tremendously to have this kind of practice. So we're going to practice it here. The number 16, how far away is that from 20? Well, that's 4. And obviously you know that, but what we're really doing is we're looking, okay, we already got 10 in the bag, so we're looking really at 6 here. The complement of 6 is 4, and that's going to give us our 20. So you see you've sort of done a mental addition here as we're going along, but these little complements here are going to help us tremendously. What about the number 12? How far away is that from 20? And that's 8. Obviously you can do the subtraction, but you just realize that 8 and 2 are complements, so that's the natural answer. What about the number 14? What's the how far away from 20 is that? Of course that's going to be 6, because 6 and 4 are complements. What about 17? Yell it out as fast as you can. Well, the number 3, because 3 and 7 are complements. What about the number 11? Well, that's going to be 9, because 1 and 9 are complements. And you can do this with any number you want, 20, 30, 40. So now let's do the same thing again, but let's go ahead and practice and yell out as fast as we can how far away the number that we're going to write down is from the number 40. What about the number 31? Well, that's 9 away from the number 40, because 1 and 9 again are complements. What about the number 36? Well, that's 4 units away from the number 40. How did we know? Because 6 and 4 are complements. What about the number 32? Well, that's 8 units away from the number 40 because 2 and 8 are complements. What about the number 34? Yell it out as fast as you can. Number 6, it's 6 units away from the number 40 because 6 and 4 are complements. Again, these are things that everyone listening to this already knows. But what you need to do is practice and get as fast as you can at it so that the numbers, you're not really doing any subtraction in your head, you're just recognizing that these are complements, you're throwing them out as fast as you can, because when we do our long column addition, we're going to be using this tremendously. Now, we've just recently looked to figure out quickly in our head how far away something was from 20, how far away something was from 40. You could practice this as you're laying in bed at night, how far away something is from 50 and 60 and 70 and so on, and get really good at it, and that's going to tremendously help you. What we're going to do here is try to find out how far away a number is from 100. And believe it or not, if you can do this quickly, it's going to tremendously help your addition skills and especially your subtraction skills, and we'll see that a little bit later. But first, let's take an example. What about the number 37? If I asked you how far away this number was from the number 100, most people would write 100 down, they would put 37 below it, they would subtract them, they would get the number, they would eventually get the right answer. But there's a faster way, and when you're doing mental arithmetic, really it comes down to efficiency and speed. So if there's a quick way that you can do something, then you really need to take it. Let me write down the answer and show you why it's faster to do it this way. The answer to this is 63, because 37 and 63 give you 100. So how do we do that quickly without actually writing this stuff down and doing the subtraction? If you're given a number and you want to know what its complement is to give you 100, then the quickest way to do that is in this column. Notice that these two digits right here sum to 10. 7 plus 3 is 10, so they sum to 10. The leading two digits right here, these do not sum to 10. They sum to 9. And that's always going to be true. For any two-digit number that you want to find the complement for, which you can almost think of these as puzzle pieces, 37 and 63, they fit nicely because together they give you 100. And you will see later that that's going to tremendously speed up your mental arithmetic when we start looking at real addition and subtraction problems. So if I gave you the number 45 and I said, quickly tell me how far away that is from 100, again, most people would really have to think for a second, but all you need to do is look. Okay, in the leading column, go left to right. Again, don't work in the right-hand column. Go left to right. For the left digit column, you're just trying to sum to 9, so I'm going to put a 5 there. In the right-hand column, I'm just trying to sum to 10, so I'm going to put a 5 there. And this is the answer. That's the complement. What if I were going to have the number 76? And I said, what is the complement of that? Go ahead and try it for yourself really quickly. What we're going to do is in the leading column, I'm just trying to sum to 9. So I'm going to put a 2 here. And in the right-hand column, I'm just trying to sum to 10. So I'm going to put a 4 here, and that's it. I don't have to really do any subtraction. I don't have to scratch my head trying to borrow or carry digits or anything like that. I'm just looking to see what fits as that puzzle piece. What about the number 57? What's the complement of 57? Quickly. Well, that's going to be 43, because in the leading digit, I just look to sum to 9, and then the trailing digit, I just sum to 10. Okay, what about the number 17? Quickly, give me the complement to give me 100. Well, in the leading digit, I'm just trying to sum to 9, so I'm going to put an 8. In the trailing digit, I'm just trying to sum to 10, so I'm going to put a 3, 83. That's the answer. That's the complement. These two fit together like that nice puzzle piece. What about 66? Quickly, give me the sum to 100. What number am I going to need to add to that? Well, in the leading digit, I'm just going to put a 3 because I'm summing to 9, and in the trailing digit, I'm going to put a 4 because I'm summing to 10. That's the complement. Finally, let's look at one final one, 81. Give me the complement of that guy to give me 100. Well, in the leading column, I'm just trying to sum to 9, so I'm going to put a 1 there. And in the trailing column, I'm trying to sum to 10, so I'm going to put a 9 there. So 19 is the answer. That's a pretty incredible thing to be able to do quickly in your head, because addition and subtraction problems, a lot of times you're trying to do borrowing and things in your head. You're going to see how this is going to help you. Also, all money is in base 10. You know, $1 is 100 cents. There's plenty of different opportunities that you're going to find as we go through these these lessons where figuring out in your head quickly how far away something is from 100 is going to be really, really nice to do, and this is the easiest way to do it in your head. Now the final thing I'll say is this little trick, if you want to call it a trick, it only works for these numbers that are not multiples of 10. So if I give you the number 60 and I ask you what do you need to add to that to give you 100, you're going to know the answer is 40, but that doesn't follow this little rule here. This plus this gives you 0. It doesn't follow the nice rule that we have here. If I give you 20, then the nice complement of that guy you should already know is 80, because 2 and 8 are complements. But it doesn't follow the little thing I'm telling you here with the first column and the second column. So for the nice multiples of 10, you're going to use your knowledge of regular complements to give you the answer. For any other number, I can throw out anything. I could throw out 51. Well, I can say the complement of that's going to be 49. Because this sums to 9 and this sums to 10. So that's going to be it. I'm Jason with MathTutorDVD.com. I hope you've learned something here. Knowing your complements, and not only just knowing them from a textbook point of view, but knowing them on the tip of your tongue and getting really comfortable with them is going to help you tremendously when we start adding columns of numbers, which we're going to do in the very next section. And we're going to give you the tools to build the skills that you need to succeed with mental math. Hi, you're watching Mental Math Secrets, your secret weapon for success. And I have a question for you. Can you multiply 42 times 11 in your head? Keep watching to find out how. My name's Jason Gibson with MathTutorDVD.com. Multiplying by 11s is quite easy. So anytime you're multiplying a double-digit number times 11, do the following thing. Take the 2 digits of the other number that you're multiplying by, so in this case 42, and we're going to add these numbers together. The 4 and the 2 is going to give us 6. So these two numbers added together give us 6, and then all we do is sandwich this 6 in between the 4 and the 2 from our number, and this is the answer, and you can come up with that almost immediately. Now, continuing our practice, what if we had 31 times 11? 31 times 11. So what we do is the same thing before. We take these two numbers, we add them together. 3 plus 1 is going to give us 4, and then we take the number that we found and we sandwich it in between there. So what we're going to get is 3 from here, sandwich the 4 in that we just got, and then put a 1 at the end, 341. And that's the answer. And you can certainly do this in your head. Now what if we had 63 times 11? So again, this is going to give you 9. 6 plus 3 is 9, so you just sandwich it in between there. So you're going to get 6, 9, 3. And that's the answer. You add these two together, that gives you the 9. You sandwich it in between your digits. What if you had 72 times 11? 7 plus 2 again is 9. So we take the first digit here, we put the 9 that we get from adding these together in the middle, and then we keep our last digit 2. 792. Now what if we have a different number like 38 times 11? So we proceed the same way initially. 3 plus 8 is going to give us 11. 3 plus 8 is 11. And so let's go ahead and just try to see what would happen if we do that the same way. We'll take a 3, we'll sandwich in our 11 right here, and we'll sandwich our 11 in between the 3 and the 8. Well, obviously this number is too big. There's no way that 38 times 11 is going to be over 3,000. So this is wrong. But we're on the right track. What we end up doing is we keep the second digit, and this first digit here, let me rewrite it, 3118. What you're doing in your head is this, there's too many digits here, so you sort of take these two digits here and you add them together. It's sort of like carrying the 1. So 3 plus 1 is 4, 1, 8, and that is the answer. And you can also think about that if you want to just think mentally about what you're doing. When you add these together, you're getting 11, so you go ahead and write it with the second digit, 318, and you're carrying this one over to the next column, so you're going to get 418. That's just a different way to think about it. Now what if you had 88 times 11? Well, when you add these together, 8 plus 8 is 16. So you would think that if you're following the same technique, you would put the 8, 1, 6, 8. But that's too many digits. When you have two digits in the middle like that, that's too big. So all you do is you take the first two and you add them together. 8 plus 1 is 9. You keep the 68, 968, and that's the answer. What What if you had 49 times 11? Well, 4 plus 9 is 13. And if you were doing it the same way, then you would have 4139. But that's too many digits, so you just add the 4 plus the 1, giving you 539. 539. Now you might be wondering, can I do the same technique for larger numbers? Let's look at 127 times 11. It would take you quite a long time to multiply this by hand the traditional way. Let's see what we get. Well, we obviously have 3 digits. You don't add them all together. What you do first is you add these two together, the first 2 digits, right? So 2 plus 1 gives me 3. And then you separately add the second 2 digits. 2 plus 7 gives you 9. And then you sandwich these digits between the first and the last digit. So what you're going to get is 1 from the front, 3, 9, 7. So you add these two to get 3, you add these two to get 9, you sandwich 3 and 9 in between the first and last digit of your problem. Okay? Now what if you have 342 times 11? You have the same thing. We'll add the first 2 guys. 3 plus 4 is going to give me 7. 4 plus 2 is going to give me 6. And so to find the answer, I sandwich these guys between the first and last digit. 3, 7, 6, 2. And this would take you quite a long time to do by hand. Okay, now we're going to have a quick drill to practice what we have learned. If we're going a little bit too fast, don't hesitate to pause the video and work it out either on paper or in your head. This type of thing just takes practice. Like anything else, you have to practice it. So you work these, get a sheet of paper, grab a calculator, practice, practice. Before you know it, you'll be doing this in your head in your sleep. First problem, let's say we have 17 times 11. What would that equal? 17 times 11. Okay, so the answer to that would be 187. Because 1 plus 7 gives us 8, we sandwich that in between the 1 and the 7. What about 25 times 11? What would that equal? Your time starts now. Alright, 2 plus 5 is 7, so we just sandwich that between the 2 and the 5. 275. Problem number 3. What about 39 times 11? Your time starts now. Alright, now this problem is a little bit weird because we have the 3 and the 9. We add them together and we get 12. So we have 12. We have too many digits to wedge in between here. So we have 12. We're going to end up carrying that leading 1. 3 plus that leading 1 is going to give me 4. And then the 2 from the 12, and then the 9. Just like we learned, 429. Because we can't put 12 in between here, so we try to do it. We end up adding the 1 with the 3, giving us 4. 4, 2 from the 12, 9. 429. What about 69 times 11? Your time starts now. Okay, so 6 plus 9 is 15. So 15, we can't put 15, we can't put 2 digits in here. So we're going to end up adding that leading 1 with 6 to give us 7. The 5 from the 15 stays there, and then the 9, 759. So again, 6 plus 9 is 15, the 5 stays in the middle, the 1 gets added with this to give us 7, 759, 759. What about bigger number, 534 times 11. 534 times 11. Your time starts now. Alright, now we have a 3-digit number, so the first thing we do is 5 plus 3 is going to give us the 8, and 3 plus 4 is going to give us the 7. And nothing is too big to wedge in there like that, and no one have any 2-digit answers, so we keep the leading digit 5. 5 plus 3 gives us the 8, 3 plus 4 gives us the 7, and we keep the last digit, which is a 4. 5, 8, 7, 4. 5 plus 3 gives us the 8, 3 plus 4 gives us the 7. We sandwich it all between 5 and 4. Final problem, what if we have 815 times 11? Your time starts now. Okay, and to do this one, we add the first two digits. That gives us 9. So we're going to keep the 8 in the front. 8 plus 1 gives us 9. We add the last two. 1 plus 5 gives us the 6. And then we keep the last digit of 5. And that is the final answer, 8965. So that concludes this lesson on how to multiply by 11s. It's a really useful thing to know. It's very good for you to know and use on your exams and your tests. Follow these tips that you've learned in today's lesson and also in the future lessons that follow to get an edge in school, workplace, and an edge in life. Remember to subscribe to Mental Math Secrets in iTunes, and have a great day.
Hi, I'm Byjumax and I blog byjumax.blogspot.com. Welcome to Vedic Mathematics Part 2, Tips and Tricks. Those who have missed first part, you can watch the same in my blog byjumax.blogspot.com. Today's screencast I am going to discuss how to find the square of a number using working base technique. I have written the Sanskrit rule in quotes. So that means whatever the extent of deficiency from base, lessen it from the given number still further to that very extent, and also set up the square of deficiency. That is the translation of that particular rule. Let's go and see some example, and I apply this rule and find out the square of number. Now we have to find the square of a number 8 using Vedic mathematics method. So the number is 8. Now I have taken base is equal to 10. So the other bases are 100, 1000, etc. Since 8 is close to 10, I am taking base as 10 in this case. I have to first find the deficiency from the base, that is number minus base, that is minus 2 in this case. First part is 8 plus minus 2 is equal to 6, that is number plus deficiency, and the second part is deficiency square, and the result we get is 64. That is by combining first part and second part. So this is what actually the rule means. So whatever the extent of his deficiency from base, in this case deficiency is minus 2, lessen it from the given number. So 8 minus 2 gives us the first part, that is 6, and also square of that deficiency. So minus 2 square, 4. The same holds good for excess also with addition, so that I will discuss later. Let's do example 9 square. So base is 10. Now deficiency, I'll just write DEF. 9 minus 10 minus 1. First part is 9 minus 1, 8, and the deficiency square, that is 1. So the answer is 81. Now take an example of a number which is greater than 1, say 11. So 11 minus 10 gives us a plus 1. So instead of deficiency, it's excess. So I'll just write EX. So excess is 1, and the first part is 11 plus 1, 12, and the excess square, that is 1. So 1 to 1 is the answer. Now here I have taken a number which is close to another theoretical base, 100. So deficiency 92 minus 100 minus 8. First part 92 plus minus 8 is equal to 84. Second part 8 square, 64. The final answer is 8464. Now in this slide I'm going to find out 18 square. So the base is 10 and excess is 8. The first part is 18 plus 8, which is 26, and second part is 8 square, which is 64. But if we combine first part and second part, we will get a 4-digit number. But 18 square is a 3-digit number. So what we have to do is that we have to add the excess 6 to the first part. So which gives us 32. So the final answer is 324. The same example can be worked out using with a convenient base. So what is this convenient base? So actual base or theoretical bases are 10, 100, 1000. But the number 18 is close to 20. So we'll take 20 as our convenient base, and we'll follow the steps what we have seen earlier to arrive at the result. So the deficiency 18 minus 20 gives us -2, and the second part is 4. So since we have taken a convenient base, we have to do something with our intermediate first part. I have mentioned here intermediate first part to arrive at the final result. So 18 plus -2 gives us 16. So the first part is the intermediate first part multiplied by the ratio of convenient base to actual base. In our case that is 2. So 16 multiplied by 2 gives us 32. So the answer is 324. Let's do an example. So the actual base here is 10 and convenient base CB 20, ratio 20 by 10 2. I'm not going to write the intermediate step, and directly I'm going to write first part. First part is, okay, in between I missed one step, excess 21 minus 20, that is 1. Now the first part is 21 plus 1 multiplied by the ratio, and the second part is second part is 4. So in this case, second part is 1. In this case, this is 44. So the final answer is 441. Try out this with big numbers. Thank you for listening. That's all. Bye. Hi, I'm Baiju KM, a software engineer from India, and I blog baijumax.blogspot.com. In today's short video, I'm going to show some mathematical tips and tricks, and it's basic, not advanced, and I'm not going to discuss the applicability of the same. As the title suggests, I learned these tips and tricks from Vedic mathematics. So what is this Vedic mathematics? Vedic mathematics is the name given to ancient system of mathematics, which was rediscovered from Vedas between 1911 and 1918 by Sri Bharati Krishna Triktaji. According to his research, all of the mathematics is based on 16 sutras. These formulae describe the way mind naturally works and are therefore great help directing the students to find the appropriate method of solution. I'm not going to cover all 16 sutras or 16 principles, but I'll try to give some flavor of Vedic mathematics. So let's begin. Tip number 1, how to find the square of a number ends with 5. So here I have mentioned 5 square is equal to 25 and 15 square. Basically the answer in two parts. Let me illustrate that. You have to find the square of a number that ends with 5. So here I am taking an example, 15 multiplied by 15. So the answer is computed in two parts. First is the first figure and the second figure. Okay. Rule hint number 1. Always the second figure will be always 25. Okay, so right away we can write the last two digits will be always 25. Now how do we find the first part, that is the first digit? So this is our number 1 plus add 1, then multiply same with 1. So how much we got? That is 2 multiplied, sorry, by 1 and the 25. So the answer is 225. Okay, here star is multiplication sign. I just change it. Now let's try. So what I have done here, I have added 1 to this particular number, then I multiplied that number with my original number, which gives me back 2, and the result, the last part, is always 25. So I just combined the step 1 and step 2 results, so I got a square of that number. Let's try another example. Let's try 25 square, 25 into 25. Straight away, once again, 2 plus 1. 2 is my first figure. Then I multiply with this my original number, and the last number will be always 25. Sorry. This gives me 3 plus 1 gives me 2 plus 1 gives me 3, and 3 into 2 gives me 6. Easy, right? Again, one more example. 35 multiplied by 35. Straight away you can write the last figure. The first figure, 3 plus 1 gives me us 4. 4 into 3, 12. So the answer is 12, 25. Okay, and this is what I have mentioned here in the slide. So in general, a number that ends with 5, so here n can be n 1, 2, 3, etc. So n5 square is equal to n plus 1 multiplied by n. That gives us the first part of the result, and the last part will be always 25. Okay. Tip number 2. Method for multiplying numbers where the first figures are the same and the last figures adds up to 10. So here I have taken an example, 22 multiplied by 28. So both numbers starts with 2, and the last figures, that 2 and 8, adds up to 10. This is like same way that we have done for the numbers that ends with 5. So just 22 multiplied by 28. Same rule. What we have to do is that we have to take the original number plus 1 multiply, sorry, I always put a star, then the last number will be 2 into 8. So this gives us back 3 plus 1, 2 plus 1, 3, 3 into 2, 6, so 6, and the last 8. Let me reduce a bit. 8 into 2 gives us back 16. So the answer is 616. Let's try another number. Say 27 multiply, no, let's take another one. 37. 37 multiplied by 33. So 3 plus 1 gives us 4 multiplied by 3, and 2 plus 7 into 3, 21. So answer is 1221. Simple. That is what the second rule says. So in general, NA multiplied by NB is equal to n plus 1 into n, and the last figure will be A into B, where A and B are 1, 2, 3, etc. A, B, N are 1, 2, 3, etc. And the condition is A plus B should add up to 10. Now, multiplying a number by 11. Say take an example, 26 multiplied by 11, answer is 286. So what is the rule? To multiply any figure number by 11, we just put the total of two figures between two figures. So let's try that. What is that? Okay, just again let's try this itself. 37 multiplied by, so please note that this rule is applicable only for two digit numbers. So you have to write the first number, and the second number will be 7 plus 3 . Now let's try some small number for 34. Three plus 4, and the last number will be 4. So this is what actually meant by that rule. To multiply two figure number by 11, we just put the total of two numbers between two figures. That is what we have just done. So we just put the total of two numbers in between these two numbers. That's it. So the answer is 374. Sorry, 374. Let's take another example. Say 37 multiplied by 11. So here I have to put the first two numbers. So what will be this middle number? It's 3 plus 7. Here we got 3, 10 and 7, and everybody knows that like 37 multiplied by 11 should not be like 3000, starts with 3000. So what's going here? So if any number, see if you add two numbers and that results greater than 10, so what we have to do is that we have to just take the 1 and add it to this number. So the answer is 407. Simple. Okay, so this is a variation from the this particular one. Why? Because the middle number adds up to a number which is greater than 10. So in that case we have to just add this 1 to the first figure, so which gives us 407. Okay, it's a general rule. A B, where A comma B is equal to 1 to 3 etc., and multiplied by 11 gives us A plus B. So there is a condition which I like, the second example which I have shown you. So if I have to write something to add this to my rule, if A plus B is greater than 10, then it will be, the result will be A plus 1 and then A plus B itself. Say A plus B results in, say, small n, then B. Okay, so just add that. Now we'll move to the next tip, method for dividing a number by 9. 23 by 9. Take an example, 23 by 9. So the answer is 2 remainder 5. So how do we get that? The easy way is like, the first figure of 23 is 2. So this is the answer. And the remainder is just 2 plus 3. Okay. Let's try that. 43 divided by 9. So the answer is, first number is the answer, and the remainder 4, the remainder is 7. So this is the answer. But there are some exceptional cases that I'm going to discuss in the next slide. You cannot directly apply these rules to all the numbers. Just take an example of 124. Okay. So 124, the actual answer is, I have mentioned here, 13 remainder 7. Whoa. What happening here? So in the above case, 1 is just the first figure of 1 to 4. So obviously that comes first. And 3, what is this 3? 3 is the total of first two numbers. That is 1 plus 2 is 2 numbers. And 7 is the total of 3 numbers. So this is what rule you have to apply. Say just take another example. 125 divided by 9. So the first number is we have put the first number 1, and the second number will be 1 plus 2, that is 13, and the remainder will be addition of all these numbers, that is 8. Right? Simple. And one more exception here in this rule. Say 841 divided by 9. These are like, see, the core rule remains the same, but there are some exceptional cases that you need to like adjust your answers according to the, like, if some number is greater than, then add with the if you're like we have seen that in any number, two-figure number multiplied by 11. So sometimes you have to like adjust your number, but those adjustments will be very easy and easy to spot out. So let's take an example of this one. 849 divided by, this one example we have taken, right? 841, sorry, just 841. So here we have to put first number, and the second number will be 8 plus 4, which gives us 12. okay, and the remainder will be 8 plus 4 plus 1, which is 13. So here you can notice that the addition results in two numbers. So the same rule that we have seen while we multiplying a number, two-digit number by 11. So same rule can be applied here. So I will just add 1 to this 8. So answer will be 92 instead of 812. Okay, and the remainder is 13. So 13 is actually greater than 9. So again we need to apply the same rule. So 13 divided by 9. So the second iteration, this particular operation goes into a second iteration. So 13 divided by 9, again same rule, 1, and the remainder is 4. Okay, so the final remainder is 4, but we got here 1 that we need to add here. Okay, so the final answer here from these two iterations will be 93 remainder 4. Okay, now another tip number 5, all from 9 and last from 10 to perform instant subtractions. This always works for subtractions from numbers consisting of 1 followed by zeros. Take an example, 377, we have to subtract 377 from 1000. So what we are going to do here, all from 9 and last from 10. So I'm going to subtract 3 from 9, 7 from 9, and last number from 10. So it's easy. Let me demonstrate that with another example. Say 10,000 minus 567. So all from 9 and last from 10. So I need to subtract 5 from 4. 5 from 9. So it gives us 4, and 6 from 9, 3, and 7 from 10. So that is also 3. Simple. Now we'll move on to the next tip, vertically and crosswise, and this is very powerful. How do we actually multiply two numbers that's close to 10? Take an example, 9 multiplied by 7 gives us 63. So we'll find that in a vertically and crosswise way. So first you have to take 10 as base, and 9 is 1 below 10, and 7 is 3 below 10, and think of it like below. So here so 9 1, because 1 is 9 is 1 below 10 and 7. Okay, now subtract crosswise. Either you can subtract 9 minus 3 or 7 minus 1. This is a cross to get the first digit. Okay, so either you can do a subtraction 9 minus 3 or 7 minus 1. So that will gives you the first number, and multiply vertically to get the last number, that is 1 into 3. Now let's take another example. 8 multiplied by say 7. So just write like this. I'll just write like this. 8 is 2 below 10, so I mentioned here. So and 7 is 3 below 10. So first figure will be crosswise subtraction of either 8 minus 3 or 7 or 7 minus 2, which gives me back 5, and I have to multiply vertically these two numbers, 3 and 2. That gives me 6. Easy, right? This rule can also be applied to the number that are close to 100. Just take an example, 88 multiplied by 98, which results in 86/24. So 88 is 12 below 100 and 98 is 2 below 100. So either now first you have to do a crosswise subtraction, either 88 minus 2 or 96 minus 12. That gives us back 86. That is the first portion of the results, and the second, to get the second portion, we have to multiply vertically, that is 12 multiplied by 2 to get 24. Let's try an example. Say 98 multiplied by 92. 92 is 2 less than 2 below 100, so 2, and 92 is 8 below 10. 100. Either we can take 98 minus 8 crosswise, or 92 minus 2. So the answer is 90. The first portion is 90, and we have to multiply 8 into 2, which results in 16. So answer is 19, 16. 90, 60. 16, sorry. So that's all for this short video. Thank you for listening. Have a good time. Bye.